So this is our last tissue lecture. We're going to move on to skin in our next lecture. But this lecture is all about tissue repair. So what is tissue repair? It's the process by which we replace dead or damaged cells. So cells that are no longer functioning need to get out of there so that we can have cells that are functioning. And with tissue repair, it has two possible outcomes. And those two possible outcomes have really broad categories of repair and resolution. And with repair, the interesting thing is that we have a maintenance of the original functionality. Versus with resolution, we lose that original functionality. So let me explain. Let's start with resolution here on the right. And as you can see, we have an injury here. Let's say this is a blood vessel. We have blood running through it, and now we have an injury that has ruptured that blood vessel, and blood is spilling out. With resolution, we just cap off both ends of this blood vessel, and the problem is solved. We no longer have bleeding outside of the blood vessel. But we have lost the functionality of this blood vessel. Blood can no longer pass between these two sides because it is separate now. This is resolution. Repair, on the other hand, is where we keep that original functionality. We are able to repair the structure so that the original functionality of allowing blood to flow through the structure is maintained. And there are lots of different factors that can influence the outcome of whether or not we lean more towards resolution or repair. And we're going to talk about those different factors, but there are lots of different things that could influence it. So this is a chart you have in your notes. And I'm going to talk through this so that you have some time to kind of write down each of these things. And this is all about the possible outcomes we see. So whether or not we have a lot of regeneration and healing, or whether or not we have a lot of scar tissue, is kind of determined whether or not we hit several different factors as we go through this chart. So the first is whether this is an acute injury right here or persistent. So an acute is a single time instance. If we have an injury happen just once, we are more likely to end up with healing and regeneration. If it's persistent, then we might see scar tissue. This is one of the reasons why people tell you, don't pick at scabs, because if you remove a scab too early, you can actually cause tissue damage that's more likely to leave scarring. So that's why those scabs are so important to leave in place, so that you stay on the acute side of the injury. Now, there are some terms down here that are going to be really important for you to understand, and that is parenchymal. Parenchymal cells are cells that are carrying out the function of a tissue, and we're going to define these terms in a little bit, but just so you kind of know where we are, just be kind of understanding that parenchymal tissue is the tissue that carries out the function, and then we're going to have some other structures called stroma, which are supportive tissue that also are going to play a role here. And we're going to come back to this chart and add to it a little bit later, but I'm just going to keep flowing through. So as long as parenchyma cell death is really minor and we have a lot of the framework still intact, we're going to see regeneration. Regeneration is the restitution of the original structure or the normal structure, basically what we think of as a full repair. There we have maintenance of the original functionality. If we have some damage to the underlying framework and we have kind of a deep wound, we're going to lean towards healing, which is where we're going to see some scar tissue, but really it's got some of its original functionality, but just some minor scar formation. On the flip side, if we have really persistent damage, that's where we see fibrosis, which is the formation of thick scar tissue. And this is where that can become really dangerous for functionality. So what are the stages of a tissue repair? There are 3 main stages. We have inflammation, which is where the capillaries around the damaged area dilate and allow for more blood flow and white blood cells to hit that spot. And then we have organization. This is where granulation takes place. Granulation is the process of cell division that's going to start linking together the 2 sides of the damaged tissue. And this is also where you have fibroblasts increasing. So fibroblasts are also going to go through mitosis and increase in number so that they can create collagen fibers that are going to help bridge the gap. So those collagen fibers are going to move across to the 2 sides of the damage and are going to interlock and start bringing the 2 sides of that injury together. And then we have regeneration, which is also called remodeling. This is where the tissue repair is finalized and refined to look like the surrounding tissue. So this is where we would hope to see more of that return to original functionality. So here is kind of a chart to show you how long it takes for each of these stages. So we have inflammation, and then we have the granulation stage, and you can see those overlap. So you're not waiting for one to end before the other can begin. And then you have wound contraction, and we can kind of encompass that as all of remodeling there. So you can kind of see those 3 stages in action. How do we make a repair? All cells come from cell division. So all cells come from pre-existing cells. So for any tissue repair to occur, we have to go through mitosis. So if you're familiar with any of those stages of mitosis, remember that we're going to, make copies of the DNA. We're going to have those form chromosomes. Those chromosomes are going to line up in the middle of the cell, and then they're going to be pulled apart. So all cells are going to have to, go through cell division at some point. But which cells are carrying out the repair has a huge impact on the outcome of that repair. So now we're going to kind of define those 2 terms I talked about earlier on that other chart. So stroma is tissues that support connective tissue. So this is a supportive connective tissue. Parenchyma are cells that are part of the functioning aspect of the organ. So each organ is a group of tissues working together. Parenchyma are the cells that do the organ's function. So what we would think of as a liver cell, whereas stroma is the connective tissue that supports that organ. So now that we have these 2 terms defined, I want to go back and I want to talk about this chart a little bit. And I want you to add to your chart in your notes. Regeneration, here, this is a parenchymal leaning repair. So we still have parenchyma and stroma involved, but because it's leaning more towards parenchyma, we are more likely to have normal structure regained. So we're more likely to end up with a perfect repair. Healing is where we have a stroma leaning repair. So more stroma is involved. And because more stroma is involved, we end up with, we often end up with more fibers, so more collagen. And so that can interfere with having enough cells to do the functionality of the organ. So it will still probably function, but we might have some reduced functionality in that area. So this is stroma leaning. So off to the side here, you can put parenchyma leaning repair. Here above healing, you could put stroma leaning repair. And then here, I want you to put stroma led. So that means stroma is predominantly involved when we have fibrosis. When we see excessive scar tissue, that's because the stroma is leading that repair, and it ends up being mostly connective tissue rather than parenchymal functioning tissue. So just like I said, if parenchyma is leading the repair, then we're going to get a perfect or near perfect reconstruction. If stroma is more involved, then we're going to produce more collagen and other matrix fibers, and these materials kind of crowd out the functioning cells of the organ and lead to scar tissue. And really, what's going to determine whether or not parenchyma is able to lead the repair is the capacity for that parenchyma tissue to regenerate. So you've probably heard that different body cells have different regeneration rates or different replacement rates. And that's because they have different mitotic levels. They do mitosis at different rates. So something like your skin cells or like the lining of your mouth, those cells go through mitosis a lot. So because of that, they can regenerate very, very quickly. But something like a neuron doesn't really go through mitosis very often. And so it can be very difficult for damage to a neuron to be a near perfect repair. So just something to keep in mind. And then we have some other factors that affect repairs. So we also have nutrition. A good diet or a bad diet can result in not having the vitamins and energy needed to carry out mitosis. Mitosis is a very energy intensive process, so not having a good diet can really affect that. Proper blood circulation. So blood is bringing oxygen and energy and nutrients to an area. And if we do not have good blood supply, we can't get a good repair. In fact, there is some discussion, if you've ever heard of like rice for injuries, like rest, ice, compression, elevation, they're actually starting to kind of discourage icing injuries, because icing can actually stop blood flow, and that can, cause problems for repairs. So there's actually some discussion about whether or not that is an appropriate intervention to be telling patients to do. And then age. Younger individuals heal much faster. In fact, sometimes surgeries have to be performed in utero, And if that's the case, then there is no scarring to the fetus. This is one of the reasons why if like tongue ties, which are like the attachments of the tongue and lips to the gums, are detected in children, they will often try to be corrected while the babies are like still infants, because they'll heal very, very quickly because of that. And so that's going to end our discussion around tissue repair. That is going to wrap out our tissues, and then we're going to move into skin and talk about skin, because skin is just it's like a layer cake of tissues, so it really fits in here.